So this is a course that I did several years ago for the honors program at Ithica College called Physics in Cartoons and Movies. And the premise was that instead of trying to figure out what was wrong with the physics, we saw it happen, so therefore we should be able to figure out what the physics was in that scene that we saw. So I'm gonna take you through how my students and I would go into a cartoon and analyze that scene to try to pull out what physics is happening. So as I go through this, feel free to ask questions. I like to respond to things along the way. Due to the lighting, it's a little bit challenging for me to see you, so feel free to just shout out that you have a question. So this is the program that we're gonna use. It was written by physicists to analyze the motion of objects. And it's a free piece of software that works on all the various operating systems. It's at phizlits.org tracker. Here's the program itself. So I can go in and open up a movie segment. So this is one of the movies that comes with the software. And so what we see is it's just a person tossing a ball. They've set it up to make the analysis a lot easier. So notice there's the black background. This is a sense of scale. So what I want to do is find where the ball first releases. So I'm just clicking frame by frame. Right there, we know the ball's out of the person's hand. So I need to set the scale. And I happen to know that this is a meter stick. So I'm going to click there, click up top, and tell it it's 1.0 meters. So I need a coordinate system, because I want my measurements to be referenced to something. So this is the next tool. I'm going to position that right at the ball. And I'm gonna use a point mass analysis. This is where I'm just gonna click as best I can on the object, and we're gonna now track it as it goes through the air frame by frame. And so what that did is it gave me the time window. We're a couple frames in, so we're at 0.34 seconds. And then it gave me an X location and a Y location. And notice it moved the frame forward one. So I can click a second time. The number you see assigned to the position is the frame we're on in the movie. So that was the 12th frame I just clicked on. So I could keep doing this, and we can start seeing the motion of the ball. Over here you see a graph is being created based on these data that I've identified. And I can change it, I can show its X position, I can show its Y position. One of the things that's neat about this software is that I can automate things if the scene is set up right. So I'm just going back to that starting point, and now I'm going to have the software automatically find the ball as it goes. So the first step in auto tracking is I have to tell it which object I want to track. And instead of me having to click, I can just let the system auto track. So it had an issue in here, and again, just to show you how the software works, it's nice because it alerts you when there's a problem. And that's because as the ball came through the middle there, it had a hard time seeing it. So there's the motion of our ball, there's that missing point. and then I can bring the data over into an analysis package. And here again, you see the Y motion. This is where it's going higher in the air, and then it's starting to fall. And what I want to do is see if I can figure out the shape of those data. So in this case, I try to put a straight line through, and we can see that doesn't fit very well. So I'm going to convert this to a parabola, and you can see that that's a really nice fit. And then it gives me the equation of that line. And I know because of my knowledge of physics that this first term here, this A, is related to the acceleration due to gravity. So this is a way that I can go frame by frame by frame to figure out what is the effect of gravity. So now let's jump over to the cartoon world. So all sorts of cool physics going on here. So remember, we're seeing it, so this is happening. The question is what is happening, and can we describe the physics? So here's a nice point for this software analysis. You can see where there's a fall starting. I'm going to get right back to where the start of that fall. Remember, we have to set a scale. So let's use the Roadrunner. How tall is the Roadrunner? Need a number from the audience. 3 feet, so about a meter. We've got to set our origin. And what I'm going to do is track the tip of this rocket ship he was on. And one of the things I noticed, I don't know if you saw that, it looks like these 2 points are really well aligned with each other, and I expected them not to be. So if I go back to these, if you watch the frame, this is me going from one frame to the next. And you notice nothing's changing. Cartoons do this all the time. They put duplicate or triplicate frames in to give a sense of slow motion. And so if you're analyzing the cartoon using the software, you have to be aware of that, and then we need to come in and get rid of one of these points. Because it really is just a duplicate of the frame. Rid of it over here. So similar thing, I'm going to do a fit. I'm going to have to grab the points again. I don't know why it hung on that particular data set for me. So we're going to just do this again quickly. There we go. All right, so there's my fit. And what I'm seeing here is I'm getting something that's about almost 200 times the gravity that we experience here on Earth. And so there's a lot more that I could do with this software. I just wanted to give you a flavor of the type of analysis. And what I think is really exciting is to now, in this world, even though that gravity is 200 times ours, is it consistent? Is it the same across the different frames in the different segments? And so here's another clip that you can imagine all sorts of analyses we could do. One of the things to look out for that is challenging when it's not something you've set up in a laboratory where you can control everything, you'll notice that the camera in these cartoons looks like it's doing all sorts of motion. It'll pan, it'll dolly, and that means your coordinate system is going to move around. And so you have to move the coordinate system if the camera is also moving. So the analysis can get a little bit more complicated. So one thing we could do is try to figure out how springy is this spring. So here's an example of where the camera's moving along in the scene. So this would be more challenging to analyze with the software. So this brings in a magnet, so we could look at what's the strength of that magnet. So we have to deal with the fact that gravity doesn't work instantly. And so here's another fall where we could gather data during this fall and compare it to the one from the other scene and see if it's a consistent effect of gravity throughout this whole genre. So that's just a little window into how you might go about looking at cartoons, but also movies. My students looked at the Matrix movies, which were really good because you had people doing all these big jumps. And again, going frame by frame, you can extract a lot of information about what is happening for the physics in that world. So, any questions or comments? That's what I would do, and then it's difficult to compare them, but if you can put the new coordinates in while the old one is still there, you can cross-reference them. Okay. So you can keep adding additional coordinate systems. We've got some fun cartoons to watch.